Hello, welcome to our lesson on 4.07, Transforming Linear Functions. This is for October 19th, 2018, Friday. Happy Friday. I hope that you all have a fantastic Friday and weekend. And before you kind of wrap things up for the weekend, hopefully you find yourself caught up with at least Unit 4, Instructional Cycle 2 in Algebra. We had 3 quizzes this week. Today is going to be your last quiz for the week on transforming linear functions. And we're going to go through all of the details of the concepts in this lesson. And we're going to go through 5 examples. And these 5 examples are going to mirror the 5 examples on your actual quiz. So it's a little bit different than how I've done class and recordings in the past. So the 5 questions that we do in class today in this recording are going to be just like the 5 questions on your quiz. So hopefully if you open up your quiz as we're going through, you can take it as you're watching this recording, which will be really beneficial. So a transformation. You can think about it literally in terms of a transformer. So you're taking something and you are transforming it. You're changing it somehow into some future view. So there are several translation types that we're going to talk about where we're given our original function, f of x, okay? Original. And then we transform it to a new function, g of x. Now we just typically use this notation f of x to g of x, but just know that you could use different names for your functions, but all of our examples, I believe, use f of x to g of x. Another word that isn't really mentioned here, but that we will discuss in the future, the original function f of x is also called a parent function. I think that terminology is important for you to know because it will come back and we'll use it again. So just know that f of x, that original function, is also referred to as a parent function. So we're going to talk about some different types of functions. We're going to talk about horizontal transformations where we shift the graph left to right, so along that x-axis. We have vertical transformations where we shift the graph up or down. We have a vertical shrink, or what we call a compression, or a stretch. And then we have a horizontal shrink, or what we call a compression, or a stretch. And just know that these, in terms of linear functions, are kind of opposites of one another. So the stretch and compression are, the vertical stretch is similar to the horizontal compression, and then vice versa. Okay, so they're kind of opposites of one another. And I'll show you that graphically and what that looks like once we get to those examples. And in terms of a linear function, what these are going to look like is really the steepness of your slope. Okay, and then lastly is the reflection, or another word for reflection is flipping or flip over the x-axis and the y-axis. So we'll take a look at what all of these look like in just a minute. So the first one we're going to look at here is our horizontal translation. Okay, I know there's a lot going on this page. We're going to kind of go through this one piece at a time. All right, took a second to kind of cover some things up just so we're not overwhelmed when looking at our slides. So the horizontal translation, remember that horizontal is left to right when we're looking at our graph, and we're looking at changes to the input. So consider the changes from f of x to g of x and how they change the input. So if we're given some function, it doesn't matter the function, if we're given some function f of x, if we change the function, by changing the input. So we're changing the input by subtracting k. This is going to slide the function horizontally. So it's going to slide the horizontally right when k is greater than 0. Okay, so let's say that k, if it's greater than 0, let's say that k is 2, because that's bigger than 0. So if I were to plug that in to this function here, I would have f of x minus 2, because the formula here is minus k. Okay, so notice that it's opposite the actual value of k. K is positive, but when I plug it in, it's an opposite sign. So likewise, let's say that k was -5, because it's less than 0. So if I plug in a negative into this function, f of x minus k, two negatives, we know that those make a positive. So this would actually be f of x plus 5. And again, that sign is opposite what we're really doing. So if we're moving right, which would really be in the positive direction, because right on the x-axis is in the positive direction, when we look at the function notation, it's going to show a -2. It's going to show an opposite. It might not be 2. It could be -8 or -2.4. That's just telling us how many units we've moved in the direction to the right. Whereas if we've moved left, that means we've gone in the negative direction. When I plug in that negative, those two negatives are going to make a positive. So again, my symbol is opposite. Okay, so let's look at some examples here specifically. So if I had the function, if g of x equals f of x minus 4. So I have this -4 here. So since it's a negative, that really means I'm moving right. Because when I pull out that value, it's going to be a positive because the formula itself is negative. So the graph of g shifts right 4 units from the graph of f. And then if I were to have a positive 5, I'm actually moving in the left direction. So just remember that the symbol is opposite what's really going on when we shift. And I'm going to show you what that looks like in a second. Another way to think about this in a more specific or example, given that f of x, so here we actually have our function for f of x. So this is, remember that a function notation, when we have a linear equation, can also be written as y equals, okay? So if I write it as an equation notation, I have y equals 3x plus 4. In function notation, it's f of x equals 3x plus 4. This is telling me how my function has moved, how it's changed or translated, okay? This is my transformation. So this is telling me I've got x minus 2, remember it's opposite, so this is telling me that I'm moving 2 units right. Because the sign is opposite. So just like we did in this example here, if I'm moving x minus 2, my k value, or my value that I'm moving, is really positive 2 units. So if we were to actually figure out the new function, what we do, and let me change, can I change my, there we go. I'm going to go ahead and highlight. We replace the input value. So we replace our x with the entire translated function here, this x minus 2. So notice in my equation here, I have 3 times x. So I'm going to take this x minus 2 and I'm going to plug it in where I have this x. So here I've got 3 times x minus 2. I've just picked up what my translation is. And I'll draw one more arrow just to kind of reiterate my change here. So I'm taking this value and I'm plugging it in for this x. So the 3 stays the same and the 4 stays the same. I'm just swapping out this value. When I do that, I can simplify by distributing those 3 through. So 3 times x is 3x, and then 3 times -2 is -6, and I still have the plus 4 at the end. These are like terms, and -6 plus 4 is -2. So my new function for g of x, after I've translated it, is 3x minus 2. So really quick, let's look at what does this look like on a graph, okay? So I'm going to go ahead and pull up my, here I have a function, okay? So I have a function 3x plus 1. It's graphed for me right here. So I'm going to say that just like in this last example, we have a new function g of x, and all I'm doing is I'm taking f of x minus 2. Notice how it took my red line here, my red function, and it moved it over 2 units. I think you could actually see this better if I have it at 0. So if my x-intercept is right here, you can see how I've moved it in the right direction. I've moved it over 2 units. And likewise, let's say I have another function. When I have a plus 2, remember this is opposite, I'm really moving in the left direction, so you can see that this function has moved to the left 2 units. So this kind of shows you how it's opposite. So if it's a minus, I'm really moving in the positive direction 2 units, and if it's a positive, I'm really moving in the negative direction 2 units. All right, so those are my horizontal translations, okay? So let's look at an example of vertical translations, and then we'll do a couple examples that will hopefully help solidify some of things because you might have some questions. So vertical translations are changes to the output, okay? So remember that the output, that's my f of x. That's the entire thing. That would be like my y. So we're still starting with f of x. That's what we're starting with. That's my output. But notice when I move vertically, we add k to the end of our function. So it's f of x plus k. That plus k is just tacked onto the end. As opposed to when we had a horizontal translation, that k was inside of my function. So when it's horizontal, it's inside the function. When it's vertical, it's outside the function. When we're moving vertically or up or down, it's true to whatever sign you see. So if it's a positive, that really means we're moving up. So if I had f of x plus 4, this really means I'm moving up 4 units. And if I had f of x, let's say minus 8, this really means I'm moving down 8 units. Okay? So another way of thinking about it, let's see, I'm going to the vertical rule, I'm going to come on. Tells the truth. And my horizontal lies. Okay, so that kind of helps us with our remembering the rules. So let's look at an example. So if I have f of x plus 3, that means I'm going to shift up 3 units. I'm going up 3. And if I were to have f of x minus 1.5, this really means I'm moving down 1.5 units. So we can see that graphically if I were to bust out this here, and let's say we start with the same thing here, but I add 3, notice how my x-intercept has just changed. I've just moved my x-intercept from 0 up 3. I've just shifted this line up 3 units. And if I were to subtract 1.5, I've simply taken my red line, or that original function, that parent function, and I moved it down 1.5 units. All right, so looking at this even with some more detail, if I gave you the original parent function of 3x plus 4, and then I told you that my translated function is f of x plus 2, we literally just tack on the plus 2 to the end of my function. So we take the entire output, the entire f of x, that is the 3x plus 4, I'm just dropping that in right here, and I'm just tacking on the plus 2 at the end. When I simplify, 4 plus 2 is 6. This is my new function after it's been translated. And that is that, okay? So let's look at a couple examples. This question 1 is just like the question 1 on your quiz. So it says, which statement correctly describes the relationship between the graph of f of x and the graph of g of x equals f of x minus 8. Okay, so f of x, this is our original or parent function. Okay, and g of x is our new or translated function. Okay, so if I have a minus 8, I'm just tacking it on to the end. I'm going to put up here's all the rules that we just talked about. Okay. So you might want to pause and write those down just so you have them handy. I also shared out in the email the graphic, well, it's not really a graphic organizer, but it's a PDF with the rules that kind of summarize the same thing. So if you have f of x minus k all in parentheses like that, or f of x plus k, those are the horizontal rules. Okay, and remember these are opposite. So if I have a subtraction sign, I'm really moving in the positive direction, or moving right. Where if I'm moving left, I'm really moving in the negative direction, but my function looks like it's positive, so that they're backwards. Okay, when I'm moving vertical, I'm just doing what it says. If it says positive, I'm actually moving up, and if it says negative k, I'm actually moving down. So in this case, I just have this minus 8 tacked onto the end. So when I go and match that up with the 4 different rules that we just talked about, that matches, that minus 8 matches with this minus k, which tells me that I move down. So when I look here, I'm moving down 8 units. So that means that D would have to be the correct answer because I've moved or translated 8 units down. Simple as that. Okay, so if you were to be given an example, same idea, but this time you're told that you're starting at f of x, and then the graph of g of x equals f of x plus 8. Okay, so now I have this plus 8 tacked on the end that matches with this vertical translation, and that tells me that I'm moving up. How much am I moving up? Well, I'm moving up 8 units because it's plus 8. So C would be the correct answer. All right, so that's going to be very similar to your question 1 on your quiz. Question 2, I don't know, can I copy and paste in here? No. Okay, so I'm going to go back and I'm going to look up here. We're going to be looking at these horizontal movements. I'm just going to quick write that up here. How did I write that? There we go. F. All right, so I'm just kind of rewriting what I'm going to be given. And this time notice that I'm just dealing with my input. Okay, so it's telling me that I'm subtracting 4 from the input or from the x. I have my original function, my parent function f of x, and I'm translating it to my new function g of x. And I'm translating it by subtracting 4 from my input or from my x. So when I do that, if I look up here at my rules, minus x, oops, that was not my highlighter. Here we go. Sorry about the wait. That minus x is going to match up with this minus 4, and that tells me that I'm moving right. How many units? Oh, look, 4 units. So 4 units right, or B, would be my answer. Okay, so then if I look at this bottom example here, it tells me or asks me which statement correctly describes the relationship between f of x and then the graph g of x, but this time I'm adding 4 to my input. So when I add to my input variable, I'm actually moving left, they're opposite, and I'm moving 4 units to the left. So A would be my correct answer. Okay, so that takes care of my horizontal, my left to right, and my vertical up to down shifts. Okay, that's 2 of the ways that we can transform a graph. I can also reflect the graph of f of x. And when I'm talking about reflecting something, I'm really talking about flipping it, okay? And we look at how we can flip it over the axes specifically. So f of negative x, okay, so this is changing the input, okay, just the x, affects the graph horizontally when we cross the y-axis. So this is my general rule. If g of x equals f of negative x, that's my rule. The graph of g is reflected over the y-axis as compared to the graph of f. So just the x input changes sign. Just the x. So let's say, for example, like you had a function 3 of x plus 2, and then g of x was f of negative x. The only thing that would change, excuse me, is the x. I wouldn't change anything else. I would just change this x into a negative. So my g of x function would become 3 of negative x plus 2, or negative 3x plus 2. That's it. Okay, I'm just changing that x input. Okay, whereas if I am looking at a reflection vertically, which is over the x-axis, that negative goes out front of the entire function or my entire output. Oops, output, okay? So if g of x equals negative f of x, the graph of g is reflected over the x-axis as compared to the graph of f. So this time the entire function or the output is multiplied by a negative. So if I have this same example, I start with the same function, 3x plus 2, if this time I'm reflecting across the x-axis, I'm reflecting vertically, when I go to evaluate that translation, I'm putting that negative out front of the entire output or in front of the entire function. So I have to distribute that negative to both terms. So it's going to change the first term and it's going to change the second term. And that would give me my new g of x. So if you're reflecting horizontally about the y-axis, you're just changing the sign of the x or the input. If you're reflecting vertically across the x-axis, you're changing the sign of the entire function. So you have to multiply that negative through to all of the terms of the function. So let's look at an example. The graph of g of x is the graph of f of x equals x plus 11. It's reflected across the x-axis. Okay, so let me recap my rules here. So x-axis, that tells me I'm changing my entire output. So x-axis, I'm changing my entire output, where my y-axis then would mean that I'm just changing the input or just the x. So for the x-axis, if I'm changing the entire thing, I'm taking that x plus 11 and I'm putting a negative out in front of the entire thing, which means I have to distribute that negative to both terms. So that would become negative x minus 11, or choice B. Whereas in the second part, it asks me, or it says the graph of g of x is the graph of f of x equals x plus 11, but this time it's reflected across the y-axis. So y-axis, I'm just changing the input. I'm just looking at the x. So I'm just changing my positive x to a negative x. I'm just changing the sign. I don't touch any other part of my function, so that 11 is going to stay the same. So negative x plus 11, and that's going to be choice C. Again, your question number 3 is going to look just like one of these two options, just different numbers. Okay, so the last thing that we're going to look at are compressions or stretches of the graph. So if you think about compressing or stretching a graph, compressing is kind of like squishing it. You're pushing two things towards one another to compress it. Where stretching it, you're taking something like a rubber band and you're stretching it out. You're pulling things apart from one another. Okay? And we'll look at what this looks like in context. I'll show you the graph and how it changes in a second. So the first thing we're going to look at is how the graph can be compressed or stretched horizontally. Okay, remember horizontally is from left to right. We can compress or stretch the graph of f of x horizontally by having this compression factor k affecting the input or the inside of my function. I'm just looking at the x value inside of my function. When I do this for compression or stretching horizontally, my compression factor is actually, again, just like it was with the horizontal shift, how the sign was opposite. It's a similar idea in that the compression factor is opposite. So instead of, oh, I'll show you what this means in a second. But my compression factor is 1 over k. So let's look at an example. So in this case, I have g of x equals f of 3 of x. Okay? So this 3, this is my k value. But instead of this being true, okay, when I look at a horizontal compression or stretch, my k is actually lying to me. It's not telling me the truth because my compression factor is 1 over k. So I would have to put the 3 over 1, and that is my true compression factor. Whereas if I had a function h of x that started as a parent function, f of x, but I have a compression factor here of 1/2, when I put that 1/2 in the denominator, that's really the same thing as 2. When I divide by a fraction, you're really multiplying by the reciprocal. So in the second example, the graph of h is stretched by a factor of 2 as compared to the graph of f. So they're opposite what you really see. So since this is a positive 3, I really put that over k, so it becomes 1/3. And then if I have a compression factor given to me of 1/2, I'm really flipping it because I'm taking the reciprocal, so it becomes 2. So let's look at what happens when we have our graph vertically, and then I'll kind of show you what it looks like when we graph it. So vertically, this is going to tell the truth. We don't have to change anything. And this time my k, it's out front of my function. So it affects the output or the outside of the function. And the compression factor is in fact k, so it tells the truth. So here if I have 5 out front, that really is my factor, and that tells me that I've stretched vertically by a factor of 5. If I have a factor of 1/4 out front, that tells me that I've compressed by a factor of 1/4 compared to my parent function. Now notice the difference between our horizontal and vertical pieces here. Change my color. Notice that when my k value is greater than 1, when I have a horizontal situation, I'm compressing. When I have a vertical, I'm stretching. They're opposites of one another. When my value of k is less than 1, when I'm dealing with a horizontal situation, I'm stretching. When I'm dealing with a vertical situation, I'm compressing. Again, this information is given to you in that PDF that kind of breaks down the summary of all of the rules for our translations or transformations. So let me show you what this would look like here. All right, so if I have a factor of 3, and then let's say over here I'll use the 1/2 example, okay? So you can see these are color-coded. The red here, this is my parent function, that's my original, that's what I'm starting with. Then I have, in blue, f of 3 of x. So if we go back really quick, look at this horizontal rules. When my k value is greater than 0, I'm really compressing my situation. When I have a k value that's less than 1, I'm stretching it. Because they're flipped. All right, so back to this situation here where we have this parent function of 3 of x. When I have my horizontal compression here, f of 3 of x. Okay, so when you think about a horizontal compression, you're compressing from left to right. So I wish you could see my hands. If you take your hands on either side of the x-axis and you push that red line, so if I just look at that red line, if I push it to kind of squeeze it, when I squeeze it, it's going to get straighter. So it's going to have a steeper slope as I'm pushing it together. Okay, then as opposed to if I'm compressing it, stretching it, sorry, I'm pulling it apart in the x direction. It's expanding, or that my slope is getting less steep. And I wonder if okay, so I took a screenshot here just to try to help illustrate this since I can't physically show you with the way that I'm recording this. So if I'm looking here at this guy, this 1/2, okay, this is a stretch. Because this turns into, it's the opposite. So I'm really stretching by a factor of 2. And here, this is really the opposite. It's 1/3. Okay, so if you think about this, and I don't know if this might help some of you who are visual. If this is a stretch. Okay, so if I'm stretching out if you think about these arrows and you're physically taking this and pulling my red line, you're pulling this line, you can see how it's going to get further, or that slope is going to change and be less steep. Whereas if I were going in the opposite direction, if I were compressing or pushing inwards on this red line, then my slope is going to get steeper. So that blue line is going to fill in steeper because it's pushing that line inward. I might have totally confused you, but I'm hoping that some of you, at least who are visual learners, kind of see that. I wish I can't figure out how to get my webcam to work to show you because I'm using my hands explaining it, but you don't see it. Okay, so let's kind of wrap this up and look at some examples so that you can finish your quiz. Let me go back. All right, so what you really need to remember is that when we're looking at the horizontal situation, it lies. It doesn't tell us the truth. Vertical tells us the truth. So what you see is what you get. The 5 out front, that really tells me that I'm stretching by a factor of 5. If I have a fraction up front, I'm really compressing. When it's less than 1, I'm compressing. Okay, whereas over here, I flip-flop it. So if I have a k value of 3, that really becomes 1/3. Now I'm compressing. And if I have a stretch when I'm less than 1, so here I'm a fraction, but I'm really stretching by a factor of 2. So my factors flip-flop. Okay, so let's look at a question. This is question 4 on your quiz, just a different factor. So it says the graph of the function is a vertical stretch. Okay, vertical tells the truth. Okay, if it was horizontal, you'd know that it lied. All right, it tells me that it's a vertical stretch of the graph of the function f by a factor of 4. So here's my k that is greater than 1. If I'm greater than 1, it's a stretch. It already tells me that. So what equation describes the function g? So if my parent function is f of x, what is my new function g of x going to equal? Well, remember my rules for my vertical situation, for my vertical stretch. If you go back to that previous slide, my vertical stretch is going to look like this. That K is going to be out front. So my factor is 4. So 4 times f of x. That's it. That's the equation that's going to describe the function of g in terms of f of x. Okay, then lastly, question number 5 on your quiz says, what transformation takes the graph of f of x equals 4x plus 7? So this is where I'm starting. So when it asks for what transformation, I'm asking myself, how did it change? Okay, so did it move left or right? Did it move up or down? Did it flip? Which is I'm sorry, I'm drawing a blank here. If that's my word for reflection. Or did we compress or stretch? Okay, those are all of the terms that I can use to describe the transformation or how it changed. So this is my parent function where I'm starting, and I want to know, okay, so how did I change to get here? What's new? Okay, so my 4x, that part with my slope and my variable didn't change. The only thing that changed, I went from plus 7 to plus 8. So all I did to get from plus 7 to plus 8 was add 1. Well, looking through my rules, if I add 1 to the end, or just tack on, if I have f of x, and I just tack on a k at the end to my function, that is a vertical shift up 1 unit. And that's it. That's how I changed. And you could run down the list of all of your transformations that's on that PDF to kind of match up which one makes sense for the context of that situation or that problem that they give you. Okay. So a couple more things as we wrap things up. These were all of our vocabulary terms from today: compression, reflection, stretch, transformation, and translation. Compression, remember, is when we push towards an axis. So if I have a horizontal compression, I'm pushing towards my axis, okay? Or if I have a vertical compression, I'm pushing up and down in the same direction, okay? And then a stretch is going to be pushing away from one another in either the horizontal or the vertical direction, okay? A reflection is where we flip the graph across the line, creates a mirror image. Transformation is a one-to-one mapping between two sets of points. And when you get to geometry, There's going to be a lot of cool rules for transformations and how all these reflections, and you'll learn about rotations and all that jazz. And then a translation is a transformation that slides a figure in a straight path without rotation or reflection. So this is just like moving up, down, left, right. That's our translation. And these are all of the rules that we looked at. So we have our horizontal translation or transformations. That's when we're moving left to right. Vertical is up or down. And then reflections, we're flipping horizontally or vertically. And then compressions and stretches can happen both horizontally and vertically. All right, if you still have some questions on today's lesson, you need more, you can work through the OHS lesson 4.07 under content. There's also the learning targets spreadsheet, where you could go and watch another video if you still feel really confused to help explain today's lesson. And then next week we'll have small group and open office if you're still confused, you're not quite sure. But remember that the quiz, the 5 questions we went through today, they're very, very similar to the 5 questions you'll see on your quiz. There is a practice quiz as well that's in the OHS. This is that quiz. I'll have that link for you in your email. It's also in the wonderful Magic Calendar. That's where I get this screenshot from in the OHS, and it has all of the practice quizzes for this week. Don't forget, you need to take all 3 quizzes from this week. I would highly recommend that you get caught up on those if you're behind. Just a reminder that you have to have a 60% average in all of your Unit 4 quizzes before that Unit 4 test will populate for you next week. So just make sure that if you didn't do well on one of those quizzes, that maybe you go back and go through some of the material in the OHS to make sure you get it before you use one of your extra attempts on your quiz. If you have any other questions, shoot me an email, let me know. Otherwise, have a fantastic weekend, and I'll see you guys all again on Monday.